Alright, in our last lesson we talked about applications of trig functions dealing with Ferris wheels and different kind of wheel-shaped objects. Today we're going to take another turn and look at applications of trig when it talks about like seasonal or cyclic variations, like in temperature or something along those lines. So let's start off by looking at an example. On the top of your page you'll see the example here is the average temperature for Regina is hottest at 27 degrees Celsius on July 28th and coolest at 16 degrees Celsius, negative 16 degrees Celsius on January 10th. So if you look, this is our highest or hottest time in the year. So that's kind of like our starting point, because if you remember cosine, the graph of cosine starts high and then kind of comes back up. So the high point is where we're starting. So if it's not at 0, that wherever we start at is where the high point's going to be though. So let's look down at our questions here. The first thing we're going to do is we're going to write the cosine equation. Then we're going to draw the graph. And then C says we want to know what the average expected temperature for October 4th is. And then for D, we want to see how long the temperature stays higher than 23 degrees. So remember, A is our amplitude. So to find the amplitude, you have to add up, take the difference of your high and low and divide by 2. So it's going to be 27 is your highest. Your lowest is negative 16. So we will do 27 minus the difference, negative 16, and we're going to divide that by 2. So 27 minus a minus gives us a plus. 27 plus 16 and divide that by 2. When we do that, we will get 43 over 2, which becomes 21.5. So 21.5 is our amplitude. That's how high we're going from the midline to the top or the midline to the bottom. So remember our B value, B equals, and you guys should know this by memory by now, 2 pi over P, right? So our period is how long this whole cycle is going to take. And if we're talking about the year, our period would be 365. So 2 pi, because there's 365 days in the year. So 2 pi over 365. And that doesn't reduce, so we leave it as it is. Okay? Hopefully everybody's with me because this is stuff we've learned in the past. The next thing we're looking at is the C value. So again, I told you guys that the graph starts up here wherever the temperature is the hottest. So we're going to start it on July 28th. Well, to find out what day of the year, because we're talking about days of the year, not the date, we have to find out what day of the year July 28th is. So the months we're leading up to is January, February, March, April, May, June, and July. Well, we know we're going to the 28th of July. I feel like you guys are at age now to know your days of the month. So 30 days has September, April, June, and November. All the rest have 31 except for February. So January has 31. February typically has 28. March has 31. April has 30. May has 31. June has 30. And then we know we're using the 28 days of July. So if we add all these up, we should end up with 209 days. So 209 is our C value. So again, we have A, we have B, and now we have C. Okay? So this is the first time we really dealt with C, because in the past with the Ferris wheel examples we didn't have a C value because we always started high or started low on the ride. So our D value is basically where our midline is going to be. So if we're shifting up or down, and the best way to find that is to take your high and add your low and divide by 2. So 27 plus negative 16 equals 11. Divide by 2 and you get 5.5. So 5.5 would be our D value. Okay? So now that we have everything, let's write our equation. Remember, the basic function or basic equation would be y equals a. In this case, we're doing a cosine function, so cosine b theta minus c plus d. Okay? So in this case, it's going to be, move this up a little bit more, y equals our a cosine, and really up here there's a parenthesis, a big parenthesis here because we're trying to make all this go into cosine. So our b is 2 pi over 365. So b theta minus c plus d. Alright, so here is our actual function. So let's backtrack a little and go look at our graph over here. So to graph this, first of all, we know that at we're at our highest point at 209 days. I'll write that up here. So this is at 209 days. We are at 27 degrees. January 10th would be at 10 days. So at 10 days, we're at negative 16. So if you look down here at 10 days, each of these marks are 10. So we're at negative 16. And then we know that at 209 days, we are at 27. So we're way up here. And then you can always find anything in between if you want, but we know for the most part, we're kind of going like that. So there's our graph. That's just a freehand type graph. So the next thing for C says to find the expected temperature on October 4th, first find what day of the year it is. So again, we know this gets us to July 28th. So if we add, July has 31 days. So if we add 3 more to this, we know that 212 is the end of July. So that gets us through July, January to July. And then we have August, September, and October the 4th. So we got to figure out how many days does August have. It has 31. How many days does September have? It has 30. And then the 4th of October. And in total, that should give us 277 days. So we're looking at day 277. So then all we do is, remember, days are our x value, or in this case our theta, and our y is temperature. So theta is days, temperature is y. So we're going to plug in our days into theta down here in our original equation, and that should give us our value. So we'd say y equals 21.5. And don't forget that when you're doing these, you definitely want to be in radians in your calculator. And so all I'm doing is replacing theta with 277. And when I do that, I get y equals 13.37 degrees Celsius. Okay? So that's how long it takes us. So we talked in our last lessons about using your calculator to find how long it takes for the graph to, how long the graph is above a certain amount or below a certain amount or whatever. In this case, we're trying to figure out when the graph is above 23 degrees Celsius. So what you're going to do is you're going to put your original problem right here in the calculator into y equals. So we're going to put it into y equals the original. And then we're also going to put y equals 23 into y equals. Okay, so we're going to put the original in, and then y equals 23. And when you graph them, you're going to get a graph that looks just like this here. So you're going to get a second, trace, intersect, and then you're going to put it on top of here where they intersect and find out that they intersect at just a second, 173. So in one place y equals 173, and then over here we find that, let's erase it from down here, y equals, when you plug it into your calculator, 245, or x equals, I'm sorry, they're all x equals, so we're looking at days. And then you're going to subtract, so 245 minus 173 gives us 72 days. So it's going to stay above 23 degrees Celsius for 72 days. Okay? Alright, so go ahead and flip over to the back of your paper. Number one, the example number one is very similar, if not pretty much exact, from the previous page. So I'm going to skip over that for right now and give you the chance to go back and do that in a little bit. But let's look at number two on the back. Number two says the following table gives average recorded monthly temperatures throughout the year. Use month number for the x-axis. So this is like month 1, month 2, month 3, month 4, and so on. So in this case, they didn't give us like a certain high or low. They gave us a table to look at. All right, so if you think about it, the coldest day of the, or the coldest month of the year would be January, because negative 17. And then the warmest month of the year would be July. So this is the coldest, this is the warmest. Okay, so that's our low and high points for our graph. So we know that this is technically where the graph starts, because we always start at the high point. So however many days it takes to get to July 22nd, that's the starting point of the function, or it's also going to be our C value. So the amplitude, remember, you take your highest minus your lowest and then divide by 2. So a negative negative makes a positive. 22 plus 17 gives us 39 over 2, which comes out to be 19.5. So this is our A value. Okay, remember, to write our graph, we have to find B, and we know that equals 2 pi over P. If we're talking months, a full period or a year would be 12 months. So 2 pi over 12, which reduces to pi over 6. That's our B value. C is our shift back and forth. So C is when is it the hottest, and we're talking months, not days this time, so it's the hottest in month 7, so C equals 7. Okay, and then D, which is our midline, so we're going to add 22 plus negative 17, our lowest plus our highest, or our highest plus our lowest, and then divide by 2, and we should get 5 over 2, which equals 2.5. Alright, so we have A, B, C, and D. So now let's write our equation. Y equals A, which is 19.5, cosine, we're using cosine again, B, theta, minus C, plus D. Okay, so there's your equation. C says sketch the graph that approximates the temperature for the curve for the year. Okay, so we know we can kind of just go through and graph these points, or enough of them to get our data. At month 1, which is here, we are down to negative 17. So about right here. That's our low point. Month 2, we're at negative 16. Month 4, we're at 1 degree. Month 5, we're at 10. How about let's do the evens, or we'll do the odds, it doesn't matter. We just need to get July in there. So month 5, we're at 10. Month 7, we're at 22. That's an important one because it's our highest. Month 9, we're at 15. Month 10. Let's go month 11, we're at 2. Okay, so this is what it's going to look like, and then month 12, we're at negative 11. So you can kind of follow, we know this is our lowest, so we're going back up from here. So just kind of follow your points. So that's kind of what it looks like. A little crazy to draw there, but it works. So now let's look at how does the recorded temperature for September compare with the value from your equation. So if you look here, the recorded value for September would be 15 degrees. So the recorded temperature is 15 degrees Celsius for September. If we use our equation, that's when we put September's month. September's the 9th month. So we put 9 into our original equation. So we would say y equals 19.5 cosine pi over 6, and then we're going to put 9 here, minus 7, plus 2.5. So if we put in our original, into our original equation, the 9th month, which is September, we should get y equals 12.25 degrees Celsius. So according to our equation, it actually makes September a slight bit cooler than what it is according to the table. Okay, so that just, I mean, obviously the equation is a line that's of decent fit, or I won't say best fit necessarily because we didn't use enough points, but it's a good fit, a decent fit line. So it obviously will have a little bit of error to it because we didn't use every single point and do regression like we've done in the past, but in this case it's a decent fit line for our data. Okay, so I want you to go ahead and try number 1 on your own. I'll go over it with everybody at the end of class. So that's your first step, is to try number 1 here. Once you finish number 1, then you can move on and get the next assignment from me.